Today is Tuesday, March 2nd, and this is the third period class recording. First thing we're going to do is first, everybody needs to understand that our attendance is in the announcement. So we have a Google Form survey for our attendance. So I haven't fixed the Canvas quizzes yet. I might get to it today, but it might not be until tomorrow. So either way, that's how we're doing our attendance. Make sure you complete the survey. So today, we're going to review first this puzzle that we were just looking at. So this is the yellow puzzle that you guys got in class. What did Dr. Frug's wife say when Dr. Frug said he needed to spend more time studying bacteria? So that's what that said. And these are the answers. So the problem, like the actual word problem piece, says Dr. Frug has 3 kinds of bacteria in 3 lab dishes. Each dish contains 100 cells. However, in dish A, the number is increasing 10% each hour. In dish B, the number is increasing 30% each hour. And in dish C, the number is increasing 50% each hour. Complete the table and the graph to show the number of cells in each dish for the next 9 hours. T is time, A is dish A, B is B, C is C. So, reading this word problem, we should have been able to figure out the equation, the exponential equation for these. So if A is increasing, it'll come back eventually. The video is still recording, so don't worry about that. It is increasing by 10%. So that means, hopefully it's still recording because the internet just went out. We're still going to talk through. It'll be fine. If it's increasing by 10%, guys, that means that the 100% that I started with, so that's why it's 1.1, I'm keeping the 100% that I started with and another 10%. So that's why it's 1.1. So that equation for A, y equals 100, that's my starting value. My multiplier is, that's parentheses, 1.1, because I have the 100% that I started with plus another 10%. Because if I had just put 0.1, that would be decay. That's going to be decreasing because it's less than 1. Does that make sense? So if we're increasing, we need to retain the value that I started with. So we need to have that 1 there. So then that's why for B, we had 1.3. Y equals 100 times 1.3 to the x. And then for C, we had y equals 100 times 1.5, because that one was increasing by 50%. So let's see if this will come up now. Connecting. There we go. And we're back. So that's all that's really happening here. So we can see if we were to put this equation into Desmos, because that's what I did when I was trying to figure out the table to check my answers and make sure we did this correctly. If we put those equations in, and then we can use the table to find these values, or we could do this algebraically and still use Desmos. So let's look at what that would look like. Everybody go into Desmos. So we're just going to open a new blank tab. Desmos.com. Graphing calculator. And let's type these in. So if you have y equals 100 times 1.1, and to get the exponent is shift 6. I'm going to zoom out so we can see this. So there's that one. Ooh. Shift 6. The little carrot looking thing. So that's increasing by 10%. And honestly, we can do this the easy way. Copy, copy, change 0.1 to 0.3, change 0.3 to change 0.1 to 0.5. And then we can see how these are getting steeper and steeper. So we can see the difference between 1 and 3 is closer than the difference between 3 and 5, and especially 1 and 5. So you can kind of see how it's increasing at a faster rate. Now, if I wanted to know the values, I could make a table. We could do that. Or if I wanted to know a specific value, I could put x equals 9. Let's see if it'll. I don't know if it's going to let me. If we do f of. We're trying to figure out a way for it to show us the function, but it's not going to let us do it that way. So if we just enter 100, and they're just going to replace x with whatever value we're looking for. So if we want to know after how many hours, somebody give me a number. 7. So if I want to know after 7 hours, then that's my y value. If I want to know after 12 hours, then I have 313. If I want to know after 2 days, 48 hours, we have 9,701. So we can use the graphing calculator. We don't have to just use it as a graph. We can use it to help us compute as well. So we need to always remember and understand that the function is output and input. So now somebody, let's take a different approach to this. So let's say I want to know how long will it take for me to get, let's see if I can find a good example. So I want to know exactly how long would it take for me to have 500 bacteria. So if I want to know when does y equal 500, so I'm going to need to change my scale. You guys know how to change your graph settings? We go over here, and I want more y values. If I want this to have, so I can see 500, I can change that value there. And so now I can see these intersections here. So if for when I'm trying to make sure that we're looking, let's change these colors so they're not all the same. So we have red, blue, and green. So at 10%, after I'll have 500 bacteria after about 17 hours, because now we're looking at my X value as hours. So it's only going to take 6 hours for me to get 500 bacteria at 30%. And at 50%, it's only going to take me about 4 hours. So we need to understand that we can use Desmos to help us figure out these values. And this is an approach that we're going to need to use when we start these word problems, especially if we're not very sharp with our exponent rules and we're not understanding how to work backwards with these. So this is definitely going to be important for us to understand the relationship between X and Y and how to substitute the value in to find what we're looking for. Does anybody have questions about this graph or this table? I get thumbs up if we are good there. Jeff, you got any questions? You good? All right. So that pretty much covers what I wanted us to do with that puzzle. I didn't want us to spend a whole bunch of time on it, but I thought it was neat and good to see the comparison for how those change. So just keep that in your binder, in your folder for your notes. So this page So we didn't look at this page at all yesterday? Okay. So we're going to look at this page first a little bit. This is not a page that you have a paper copy of, but it is in Canvas. So if we go to the Tuesday page in Canvas, and we're going to watch that video after we look at this. So if you click, don't click on the title. So everybody stop what you're doing and just look for a second. So you see the little page with the magnifying glass at the end of the link. Click that so that it gives you a preview in this same window so it doesn't take you to another page. And that preview option is available for any file that I put a link to. So if you know you're going to have to go back to that page, just look at the preview so it doesn't have to take you to another window. All right, so everybody looking at this. So we're going to go over what's going on that page. All right, so if we're thinking about our exponential functions and the graph and its key features, just a review of what we should understand as our similarities and differences between linear functions and exponential functions. So we're still going to have graphs that are either increasing or decreasing. That's still true. But the rate at which it's increasing is what is different. So for linear functions, it was a constant rate. We were adding or subtracting the same value each time. For exponential functions, we have a constant ratio. So we're still increasing or decreasing at the same interval, I guess would be a better explanation. But instead of adding or subtracting, we're going to be either multiplying or dividing the same number. So that's what causes it to either increase really, really quickly or decrease really, really quickly. So as far as the equations, we need to understand and recall slope is m, b is the y-intercept. So in exponential, a is my y-intercept, and b is the base or the multiplier. So that b value, whatever is attached to my exponent, is our multiplier. Understand that there's not always the a value. Sometimes a is 1. So in those cases, anything that has the base and it's attached to an exponent, that is the multiplier. So for instance, in the blue example, we have f of x equals 2x. 2 is not the y-intercept. 2 is the multiplier because it's the base of my exponent. Does that make sense? All right. So if we start thinking about the graph, what happens when I add or subtract whole numbers, or what happens when I multiply? So this whole idea of an asymptote is an imaginary line that the graph approaches but does not touch or pass through. So that's just essentially saying, okay, this is the limit. This graph is never going to be higher than or lower than this value, depending on whether it's increasing or decreasing. So when our shifts happen, that's what changes where our asymptote is. So the x-axis, if our graph is not shifted up or down, is where our asymptote is going to start. It's always going to be y equals 0 if the graph has not been shifted up or down. So if we have the whole number on the end and it's positive, we're shifting the graph up. If we have a whole number on the end and it's negative, we're shifting the graph down. So this 3 out front, so our a value essentially. So here, if this is a and this is b, right? Our a value is going to stretch the range. So it's going to cause our graph to increase more. So that's what's going to just change our rate of increase. I know that last part is a little bit trickier, but do we kind of have a basic understanding of this part? Does anybody have any specific questions about that? Okay. So then here, this is kind of sort of what we're going to be doing today, just a little bit. And we're going to be using Desmos. So we have these examples here. And the way that we find our y-intercept is we set x equal to 0. So the y-intercept is when x equals 0, right? Because if I'm thinking about I'm on the y-axis, that's where x is 0. So if x equals 0, y equals 2 times 2 to the 0 power. What's 2 to the 0 power? What's anything to the 0 power? No. No. The answer is 2, but anything to the 0 power is 1. So the overall answer is 2 because 2 to the 0 power is 1. 2 times 1 is 2. So anything to the 0 power is 1 altogether. Anything to the 0 power is, okay. So if I have here for this one, y equals 3 to the 0 power minus 3. 3 to the 0 is 1 minus 3. And that's how we get -2. So we can always find our y-intercept algebraically because we know that anything to the 0 power is 1. So when we see here, we had our y-intercept was 3. And our graph was moved up 2. So that means our asymptote is y equals 2. So that's the line that it's going to approach and not cross. I know this one is decreasing because I have a fraction and not a whole number. So that's the difference between A and C and letter B in the middle. This one is decay because it's decreasing. Does that make sense for those? Okay. All right, and then this is the last part of our assignment, and I have the paper copies for you. So we're looking at these tables. We need to be able to do this. This is pretty much all you'll need to do for that part of the assignment is figure out what is the change. Is it adding the same number every time or are we multiplying the same number every time? If we're multiplying the same number every time, then it's exponential. If I'm adding the same number every time, then it's linear. And we should be able to write the equation from the table, but we're not going to focus on that right now today. So do you have questions about figuring out the change from the table? Yes, we do have questions? Okay, just making sure. All right. So, and we're not going to do with average rate of change today, but looking at, this is what we're looking at. And everybody in Canvas, open, where are we at? Open the Desmos link due Thursday assignment. I didn't need to open that right there. Go back. All right, everybody got this open? Give me thumbs up when you're here. I don't know why I did that. Give me a hard time. It doesn't want to go into student view. Come on. So when we get there, open the Desmos template link. That is here. Let me make sure this loaded the right one. Yes, okay. And you won't need the file because I'm going to give you the paper copy so you can minimize it. I'm going to play this video here after I pass out the paper copies. So So I'm going to pause the recording because the video is here and there's been issues trying to play the video over a recording. It messes with the sound quality. So I'm going to pause the recording. All right, so I paused this video over here at this point because I want to make sure that we all understand what we're supposed to do and where this stuff is supposed to go. So for the graphs, I created these two separate folders. So in the video that's embedded right now, we didn't have this template. I created the template during second period and then added it to the assignment. So this is where we're going to put the equation. So we have y equals 3 times 1/2 the x. Make sure your x is in the exponent. Then we have, make it a table. Duplicate first. Always duplicate first. And then make a table. And then we have y equals 1/2 x minus 1. Make sure you arrow over so that minus and not down. So that minus 1 is on the end and not in your exponent. Copy and make a table. And then letter C equals 3 over x. And copy. So again, for those of y'all that might not have seen how I did that, if we were clicked in the text right here and then hit enter, that's how you get the space for the equation underneath the text for that first folder. So when we're done with all of those, we can collapse the folder and turn it off so that's not in the way anymore. And we have the tables to enter at the bottom of the page. 0, 1, 2, 3, 15. So looking at that, that is clearly a line, right? And we can connect the dots if we're not sure by clicking and holding and then lines. So on your paper for these, let's jump over here. So on our paper, we should have that this is showing +1, but this is showing +5. So it's not exponential, no. And this is because my slope is 5. And we're adding it, that's why. So this was y equals 5x plus 5. You don't have to write the equation part, but that's what the equation for that is. So at the very least, we need to have showing change in x, change in y, yes or no. And if it's not, tell me the slope. So if no, tell what m equals. Do you have questions on that part? On the tables at the bottom? Any thumbs up if we're good. Missing some thumbs. Tue Mar, we good? All right. Gavin, you good? Cool. All right, so let's go back over here. About 15 minutes or so. And I'll check back in with us to make sure that we got B and C. Alright, so I'm going to go ahead and test on these other two equations and tables, and I'm going to show you guys how to put them in a folder. So the way we can do this is we're going to create two folders. Folder. We already have that part. So and this one's going to go down below because this is going to be mine. See, I don't know why they changed it. Double tap to not fast forward. Did I miss something? Then these will be the line pop-up on the far side, and then it will be in the folder. You can collapse the folder. And to add stuff to the folder, just click enter. Then equation for line B, now you have -1. So make sure that your x is in the exponent and that your 1 is in the baseline. So it is not x minus 1 as an exponent. The minus 1 is in the base. That's important. And we're going to duplicate the table. These points there. We can put a few of these. So we can see the difference between these two graphs. That my red line is approaching 0. It's approaching y equals 0. But my green line is approaching y equals -1. That's because the graph was shifted down 1. That's what that -1 did on the end. So no matter how big a number you put, because both of these functions are decaying, they're decreasing, no matter what small or no matter what super large number I put in, so somebody give me a really large number, doesn't matter what it is. 120. So you see, that just gives me a really small number. It's still not 0. It will never, ever be 0. Doesn't matter what number you put there. I could put 4,000, 40,000. And it says it equals 0 right there because the calculator is only going to be able to write scientific notation system. If I put, it's a little bit misleading because it's so close to 0 that it just gives it an approximation. It's not actually equal to 0. Will never ever be equal. Third equation equals 3x plus 2. That's a positive. It's a number greater than 1, so that one's increasing. And you can change the colors by clicking and holding. Here, we can make this one purple. Okay, so that one moved up 2. So if we look at points on this one, you'll see that my negative values, the more the negative values, is getting closer and closer and closer to 2, but it's not quite equal to 2. So if I go down here and put in -3, we're getting closer to 2. If I put in -4, we're getting closer to 2. If I put in -10, now smaller. If I put in -20, there's this 2 right there, but that's 0.00000, and then over to So I did forget to repause the recording when I started playing the video. So if that video was playing and the sound quality was bad, just skip forward. And the very end part of this video, I didn't really have a whole lot of anything super important to say. But the main thing I want us to make sure that we understand is that the tables need to be typed in at the bottom here. We can connect the dots by clicking and holding and making that connect the dots with the lines by clicking there. When you are done, when you are completely done, everybody stop, look, and listen for me, please. I feel like I'll still probably get an email from somebody asking how to do this. So when we're done, we're going to collapse all of our, or both of our folders. Make sure everything is turned on so I can see all of the graphs. You can click the little house, and actually you can zoom out a little bit. So you can zoom out some so I can kind of see a good view of your graphs. Doesn't have to be perfect, but as long as I can see majority of what you've got done, then we're good. Jeff White, are you listening? Okay. So when you do all that and you have this in a good view, we're going to click save. Then we're going to click share. Let's get all this out of the way. Copy. And then the assignment goes, actually, I'm going to leave that page open. So the assignment goes to the Desmos link, which this assignment is on the home page as well as the Tuesday page. So we can scroll here, and it's down under Wednesday because it's not due until Thursday. So we have, hopefully I opened that assignment and not the Ed puzzle. Okay, so we have that, submit the link. I am giving you guys 3 tries because I'm anticipating someone's not going to do it right the first time. So I did give us 3 tries. I don't know why this keeps buffering. Okay, so then we're going to paste. Now, the most important thing that we can make sure we do not assume that that link right there is the one that you just copied, because 90% of the time it's not the right one. So we need to Control V or right click and paste to paste the link that you copied. Yes? So no, none of y'all are going to make that mistake. Everybody's going to share the right link for the right graph. Okay? Let's see. So then submit. And that's it for that assignment. For that part of the assignment, at least. So the Desmos link is going to be graded. We do need to make sure that we have our paper also filled out, and there will be a video posted for the second page. So we need to make sure that we have our graph sketched, and you have your change listed. So we're showing change in X, change in Y from the tables and explaining how it's exponential or not. And then this is on the back page. We'll do, there'll be a recording on the Wednesday page reviewing this. So hold on to this paper because I am going to collect this paper, but your Desmos link needs to be submitted by Thursday to be graded. Is anybody done with this assignment? Okay, that's fine. I don't expect you to be done. I was just checking to see where we were at. So I want you guys to continue working on that assignment. If you need to go back and watch the video, you can. It's on the Tuesday page. If you want to just like see what I was doing, or if you missed something, we can do that. I did just add this. This was not here at the bottom of this page during second period. There are 2 CUDA assignments in CUDA Works that I will be counting as extra credit. So we're gonna get ahead of this. We're gonna have the extra credit built in so that when we have our first quiz, when we have our first test for this term, we don't completely derail or tank our grades. So we have exponent rules review and square roots. So exponent rules review is due tonight, 10 p.m. Like I said, it's extra credit. So if you don't get to it, you don't do it, you're not gonna get a 0. Probably 10. Because it's going to give me 100% score, and that's just the easiest way for me to do that grade. So it'll probably be 10 points each. I might scale it back depending on how that affects you guys' grades. But we need to, if you're interested in earning extra credit for our first extra credit assignment of T4, that is what we have, those CUDA assignments. And we have outside of class at the bottom here, we have Monday Ed Puzzle that was assigned yesterday is due today. Tuesday Ed Puzzle is due tomorrow. So we'll still have access. So if you don't do the Monday Ed Puzzle tonight, you'll still have access to do it tomorrow, but after Wednesday, it will not be available for credit. So the Monday Ed Puzzle was reviewing, and sometimes it'll load the preview, sometimes it won't. I don't remember off the top of my head what it was reviewing. Percent problems, that's what it was. Okay, I waited all that time just for it to not work. So those are percent word problems review. And this class doesn't end until 11:25, so I'm not sure why we're shuffling around like we're packing up ready to go. Okay. School is still going to end the same time. We'll still get out at 12:30. This class just got pushed 5 minutes longer because of the parade. That's all. So we still have about 10 minutes left in class, and I expect us to be working on, and let's go back to the Tuesday page, either finishing that Desmos link or it'll load. We've got the CUDA and we've got a Desmos class activity. So that daily links, this page here has exactly what it says, daily links. So instead of having all of these links separate and at the top of the module, I put them here. So you've got Delta Math quizzes, CUDA Desmos activities, Quizlet study sets, and the checking understanding, the Google Sheet, and the playlist. So if you're going to do the extra credit for CUDA we can use that link there for that. But our priority is to finish the Desmos link. What are you talking about? That's just a link to open quizzes. I don't even think you guys have quizzes assigned right now. Actually, no, that's a lie. We do have quizzes assigned right now. It's on the homepage. Key features due Wednesday. So if you guys look at the homepage, quizzes, key features due tomorrow. And looking at this is 25-point assignment. You can repeat, you can retake the quizzes. Some of y'all is kind of sad to see we'll submit a score 50% when we had multiple tries. So let's see. 3. I only have 3 people that submitted this so far. So you need to make sure you submit a screenshot of your score. Stop making that noise, please. So this is going to count as a quiz grade. And it's mostly talking about the key features of the graphs and making sure we understand how the graph changes and what it looks like. So I think I had a little bit of a review. We looked at some of these. So this was from the class recording yesterday, one of the classes. So we did go over a few of these. So it's talking about the y-intercept, understanding the word problems, all that good stuff. So if we had watched the e-math videos from last week, this should make sense. This is not new stuff. So we've got all of those there. So that's due tomorrow. No, I'm not collecting the yellow paper, and we're not done with that other page and those word problems on the back. But I'm going to end the class recording here because I have nothing else important to say.